This is ECGR 4161, lecture number 14. Today I'm going to go over something that if you've had embedded systems before, you've seen it. It is going to be state machines. The reason I do this is that it's a common concept associated with any embedded system in which robots are. So I'm going to go over the Reader's Digest version of this. This class today will include a little bit of lecture, some examples, but I'm going to have you actually do some exercises as well, and then present what it will be. At the end of the class, I'm going to have a quiz in which I will ask you to do a state machine. All right? So, when I say the word state machine, how many of you think you know what that means? Ooh, not that many. All right, if I say software state machine, how many of you think you know what that is? Mr. Hunter, you should be raising your hand. You were embedded. You should. Anybody in embedded? So what we're going to do is we're going to talk about state machines. Now, a classical state machine, and a really simple one, will be the following. Let's say I have a dishwasher. I have two modes for this dishwasher. I'll say three modes.
Yeah.
Pot scrubber. Pot scrubber consists of a pre-wash, a wash, a rinse, and a dry. A normal consists of a wash, a rinse, and a dry. And then a rinse only consists of a, you got it, a rinse.
No dry?
No dry. Yeah, we're kind of funny that way. So, the first thing to think about is, what is your, when a dishwasher is just sitting around not doing anything, what is it? Off. Another word we use for this is idle. So we're always going to start in the idle state.
But idle still means on, it's just not.
Idle's the wait state.
Idle is the wait state. But think about this.
But you don't have it on at all.
Are you always powering a dishwasher?
No.
Yes.
Yeah,
There's always energy to it. It's just not running a cycle. Yes, sir.
I have a light switch.
Yeah,
All right. I mean, besides that.
I have a switch too. I think every house pretty much has a switch.
Yeah, but it's supposed to be always powered on. You always turn off the light switch for your dishwasher?
After, yeah.
Mine has a lever. When you slide that lever across, you're able to press the button.
All right, let's start back.
The switch.
You're always energized, okay?
Sure.
I was just wondering because.
Yeah, you're always energized. This is an embedded system.
Contact has to close in order for.
So, you will always start in the idle state. And by the way, when you have an initial state and you first power on your machine, you want it to go to something. And it's always good to go at power on to the idle state.
Should you have an initialized state before the idle state to like set all
That would be
your
the
values to 0?
Yeah, stop.
Well, we're just looking at a state that says what goes on. When you first power up, it could be that, and this is typical with microprocessors, when you first power up a microprocessor, it does all the setting, and then it just sits there and waits. That is the idle state. That's all the processing that's done in that state. Now, a state doesn't mean you're sitting and doing nothing. A state means that is a condition that you're in, and you move between states based on some sort of input or some sort of trigger inside the microprocessor itself. So, what do you think would be a good state to have?
Mode select.
All right? Pre-wash. And then what would be another good state to have?
Wash.
Wash.
Dry.
And what would be another good state to have?
Dry.
Rinse.
Wouldn't
You
you
know
have?
what? For rinse only,
Wouldn't you
no,
have?
we don't want to dry.
Wouldn't you have first the other three modes, and then you will select into that, and then it will just go to those
Depends on what mode you
states?
Nope, we're just going to start and identify all of our states that we might want to have. All right? And then any other states? Dry.
So this is like when you have a garden hose and you have a different setting?
It's like a dishwasher and you
Or
have
the
the
nozzle?
No,
No.
no.
No. Not at all.
This is like your dishwasher that has different settings.
Oh, why? Have you programmed?
Pardon me?
mechanical.
All right, come back on now. Let's go on. Obviously, nobody wants to go through this class, but you're going to anyhow.
You will make us.
I will make you. Actually, you can walk out at any time.
You're gonna
Hey,
get
you won't get that quiz.
Yeah, you won't get that quiz credit at the end. All right, so
I'll just come back in. At the end.
what will move you from the idle state?
a button.
A button press.
A button press
An interrupt.
that says,
Go here.
Either pot,
mode.
either pot, norm, or rinse, or only.
right?
That's a pot script. That's pot.
This is a really simple one. A simple button press will send it there and it will start. By the way, we'll also assume, this is really simple, we're also assuming that you won't be able to cancel. Okay?
Okay.
That sucks.
Yeah. Just open it. Open it and put in whatever you want and shut it. It'll just keep running. It's efficient. Open.
Now,
It's efficient.
is there any way to go from idle to wash directly?
You press
Yes.
normal.
Normal. Button.
Normal button.
Is there any way to go from idle to rinse?
Yes.
The rinse
Rinse only button.
Just rinse button.
Is there any way to go from idle to dry directly?
No. Yes.
Don't touch anything.
There you go.
So now, let's take a look at this. When you are in the pre-wash mode, this is when you start saying stuff like, okay, we will set up a timer to end after, I don't know, 15 minutes. And also in this state, you will run motors and valves. That's the type of activity that will go on in that state. When do you think you will go from pre-wash to wash?
Once the 15 minutes pass,
Minutes is over.
Finishes.
it will wait 30 seconds and then it starts wash.
All right? We'll have some sort of timer. And it gets even more complex than this because, you know, you really should drain out all the water from there. So maybe that's another state. So we'll just do the simple one this way. So in the wash cycle, again, you will set up timer.
What about the little lever that drops the soap in? For that thing open?
That's in the
Pretty
wash.
safe.
This is simple.
I'm just
This
gonna
is
go
simple.
ideas.
They don't have one on this one. You're supposed to just dump soap on the top of all the dishes.
Kind of like we did in the old days.
Yeah.
What,
That
you wash
wouldn't
by
involve
hand?
the
Where the really cute lady with the gloves just you're like
Yeah.
you need to scrub these pots.
Going on.
It's a good old day.
Yeah.
Run motors and valves. What do you think takes you from the wash to the rinse?
Another timer. Timer number 2.
And then inside the rinse, of course, you know, again, timer, valves, motors. And then what takes you from rinse to dry?
Timer and you're gonna have the other 2 cycles.
A timer.
Because if you would do a rinse only, well, I guess some rinse only goes to idle yet.
So a timer and button, not
What's the point?
rinse.
No.
You're gonna have to have some sort of register, aren't you? Because you don't sit there and hold the button.
Correct. So when I say button, not rinse, we could just say whatever we wanted. So in this case, it could be a variable that recorded it.
What does it say? Timer and button?
Timer and button, not rinse.
Button.
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 Or if I were in Britain, a button.
I'll call your mom. And then, your mom.
And what will send you from dry to idle?
Timer
Timer
ends.
again.
Another timer.
Or sensor.
Yeah, we're making it simple, just unknown, timer. Or just always the same thing. This is a very simple state diagram.
Rinse has gotta go to idle.
It is,
Yeah, but rinse also has.
oh yeah. Good point.
-5.
Plus my favorite else in the class.
Timer and
This is a state.
Rinse. And rinse, right.
button equal rinse.
Look like an actual dishwasher.
I should have made that bigger, sorry. It's all squished together, but you know what I mean. Oh, here, see it? There. So everybody got a good idea on this?
Not really, but.
Yeah.
So, would you like to see another example?
Yes.
All right. That will be, you'll be able to see that later in the notes that I'll post.
Oh yeah?
Let us do a robot. We will call it the functionality of this robot. It will be a roam. Roaming or Roman?
Roman.
And cliff avoiding. So, what we will do is we will move forward until a cliff is detected.
How do you know? That's
Sensors.
what you wrote on my test. I said exactly that.
Got it.
We are actually defining this now.
Assumption state.
I just had to, sorry. Couldn't bite my tongue.
When a cliff is found, stop, reverse, turn, and restart. And oh, by the way, sit, idle for 5 seconds, when powered on, then run forever. So, our state diagram will look like initial state.
Set timer.
Gosh, this is horrible. So, what other state are we going to have?
Forward, forward.
And what will be the transition from idle to forward?
Timer.
The timer.
Second time.
Will we have any other state?
Reverse.
Almost.
Or stop. Stop first.
No reverse.
Reverse.
It's gonna have stop.
You have to stop first.
Well, can you do the stop and reverse in the same quote-unquote state?
Technically.
Forward and reverse would make
Yeah,
you
just
stop,
flip it
right?
over.
If you did forward and reverse at the same time, you'd stop.
But you stop right there.
I'm sorry, can you do stop and reverse in the same
No.
state?
No.
Yeah, you don't even have to stop, you can just shove it in reverse. Just skip
Okay, there you
stop.
go. You can just
Yeah.
shove it in reverse
Well, I was
or
just
stop
saying,
it
just-
from going
Either way,
forward.
it's your code,
Yeah.
so you do whatever you want.
so that way it's like less than chance of going off the cliff.
All right.
Specifically called for stop.
It can have a stop, it doesn't matter.
Wheel slippage.
Transmission.
And what's the transition between the two?
Shove.
Sensor.
Detection.
Cliff.
Fire sensor.
An IR sensor value.
Yeah.
I'd say cliff is the.
Can you do
No.
stop,
No.
reverse, and turn sideways in the same?
No.
Yeah. You just have to have one rotation moving faster than the wheel.
Reverse.
You don't.
Say it again?
Normally in a state, you don't change any of your outputs. They are constant. So you can't have a stop output and a reverse output.
But that's in a digital
That's a digital
electronics
line.
version.
That's right.
No, if you think about this, all you'd have to do is just
This is a reason.
Have- reverse on both wheels, but have one reverse faster than the other.
Yeah.
And then you wouldn't have to have stop or turn.
All right, so there's an underlying question that was coming up, I thought you couldn't have a different output
They're two
in,
different motors.
in the same state.
What do you mean?
Well, Mr. Collins over here is saying,
I mean, I guess you can, but
It's
can you have two
it's not
different
multiple
outputs?
outputs. There's only one output. It's a reverse.
Yeah, but can you have it stop and reverse, and for that matter, turn? In other words, you're changing what's going
But
on.
I'm just saying, all you need,
What's
you
the
could
point
just
of the
put,
state,
you
though?
could put stop, reverse, and turn in that, but it would really just be reverse
Are we
for
wanting it to have a
the wheels. That's all it is.
I'm lost.
this could
Yeah,
start
that's like a
another
flat
state
you guys
machine,
don't-
which would run stop, reverse, left.
Jesus Christ.
You
All
can
right.
you can do it, but it's just
You can
So I'm gonna
like,
make
you
the
can
following-
why would you want to shove all the states into one? Isn't it just better to just
Or stop, reverse, turn on it.
hey, just
no,
do,
I mean, you
just
can't
do
do
everything
that.
in one
That-
state?
That's stupid.
What, you doing
but
everything on one?
If you're
you
gonna
can
Yeah.
put those three in the same one.
Done.
All right, now keep in mind, I mentioned that this is a software state machine, all right, not a hardware state machine. So to answer your question, yes, you're right. If this were a hardware state machine, you'd want to have a different state if there was a different output. But in this case, since you're assuming a lot of different instructions and a different operation, but you want to stay in the same state. In other words, you've got a normally running straight, flat out, and then based on some sensor change,
So
You
one,
wanna
in
stop?
one if statement, you can do all this.
you do want this in one simple statement. And I just did this because I wanted to show you a simple one.
Well, this
If
is
you
more
wanted to like
complicated.
make it complicated, can't you like do a top level state machine and then have a second one?
And you can have multiple state machines, correct, if you want to make it even more complex. Poor Mr. Hill over there, you're just grabbing your head, right? The most important thing to keep in mind is that what is changing from one state to the next? Either an input or some sort of microprocessor event so excited he fell off his chair. Some sort of microprocessor event like a timer. So in this case, we have a timer that will start counting down 5 seconds. And as soon as that, is this following me? Now.
It's moving.
That's why you should.
Yeah.
That's why.
It's moving.
Scary.
That's why you should buy it.
Up here to
Put
follow.
the timer there.
So, you need some sort of microprocessor event. Now it can't see me, is that what you're saying? Yeah. See, it's not following. There's something messed up. Ignore it. Ignore it, okay, guys? So there's some sort of microprocessor event, like a timer ticking down 5 seconds, in which then it'll go to the next state, which is regularly running forward. It has its outputs, it's constant, and based on some trigger, in this case, the IR sensor, it'll stop and move to the next state. The next state could have several movements. In this case, stop, reverse, turn. And in fact, once it is done doing all of those, because it's a software, you could also move out of that state into another one based on completing the activity. So,
But if what you're saying, how do you know when to stop, when to reverse? Like, you get what I'm saying? How do you know when to reverse, how long to reverse, and when to turn, and how much to reverse?
in this case, we're programming it. We're hard coding it.
So those wouldn't be timers? You wouldn't
So those
say-
wouldn't be timers. However, we're going to do something. Now I'm going to talk
You
about
can put it as
more
timer.
detail. You can. All right? So, what I want you to do is the following. You're going to do your own exercise and make your own state machine. Oh, we got questions.
I
Yes.
think you're wrong on there.
Yeah.
You don't have that.
You need another loop
continual
into
loop.
It's
forward.
not cliff. It should stay on forward state.
Say that again.
It's going
If
forward.
there's no cliff, it should stay on forward.
You should have that
Right, that's
loop
why it's the
there.
IR sensor.
No.
No.
It's
But you don't.
He's going to
By the
AR.
way, in a software state machine, it's assumed that you just stay there. You don't need a loop because it's.
Well, if you do it
there's
VHDL,
nothing. There's no input.
that's
This isn't VHD.
There's nothing changing.
so far.
It's not VHD.
So it's only going here if the IR sensor triggers it, as opposed to a hardware state machine where it would be not IR sensor. All right? So when we're talking about software state machines, we're only worrying about changing the transition. Now, as has been pointed out, this is very simplistic, and it's not actually representative of our Danny robot. If you think about our Danny robot, when you have a reverse, you kind of hard-coded it for a certain amount of time, right? You can also hard-code it for distance. And what will be the hard coding for that distance? What is the trigger for that?
some motor drive.
Encoder or something. Encoder.
It's the encoder, right?
What's hard code?
Pardon me?
What's hard code?
Basically, you're saying, I will turn, or I will count exactly 200
Milliseconds.
pulses from the encoder backwards. As opposed to saying, I will go exactly 1 second backwards. So in this case, what you're saying is that your encoder is going to be serving as your sensor as opposed to the timer if you're going back a certain amount of time. So it could be one or the other, right? Whatever you identified up front. So from that respect also, to turn, you can identify that you are going to hard code you're going to have a hard-coded time. In other words, a timer, you will say, I will count down a certain number of seconds or milliseconds. As opposed to saying, you will hard code for distance, again, using an encoder. Now, I'm going to add another possibility. I'm going to add that you have a ultrasound sensor points to the front. And it will avoid walls as well. So if you're within 10 centimeters of a wall, you will also stop, reverse, turn. But here I'm going to make it even more interesting. Stop, reverse, turn might work, but when you turn, you might get yourself in a corner, right?
Yeah.
So should you check for in front of you as you turn, before you turn, or after you turn?
Before.
Well, you said the sensor's on the front, so
No,
you have to turn
as
first
you
to
turn.
be able to see.
Yes, as you turn.
Can you just turn the sensor to the side?
You said the sensor's on the front.
It doesn't matter. The sensor on the then you can move to the sides, right?
Was that a fixed sensor?
Or should you make the assumption that if you're going forward, you definitely can go backward, and you can definitely have enough space to turn in place. And maybe as you start going forward again, you're checking immediately for something in front of you. Does that sound reasonable?
Yeah.
So, what I would like you to do is, we will have you turn to your neighbor and try and figure out what this new stake diagram is going to look like.
Can you move it up so it can be
What does that say? Avoid walls.
Avoid walls as well.
10 centimeter.
10 centimeters, within 10 centimeters of wall.
I would say strip, reverse, stop. That was a joke.
That's a stop. All right, so spend a couple of minutes doing this. This will be good practice for the quiz. If you can pause.
Yeah.
Using a tap.
All right, we're recording. All right, one thing I need to add on to this is that I had to, during the break, I had to kind of rewrite this a little bit. So if you were starting to solve the problem and didn't stop and were having difficulty with it, here we go. Here's what I said. Move forward unless the ultrasound sees a wall within 10 centimeters. Infrared detects a cliff. If a wall, back up 30 centimeters, turn 90 degrees, continue. If cliff, back up. The assumption that I'm making is that you can at least back up 30 or 50 centimeters, depending, and you always had the space there. I always pointed out that may not always be the case, but that's what we put out, all right? If while turning you detect a cliff, do the backup task. So should I show what my solution would be, or anybody want to present theirs? You're really proud of your stuff, aren't you?
Yeah.
All right, all right.
Right here.
Or do you want another trip to the prize closet?
Oh yeah, that's what we're really.
Dude, what is
You have candy in there?
No, I eat all the candy.
But you gotta, I don't want to trip
Yeah,
through it.
Sounds like
Yes. While turning.
No, but I have toothbrushes and toothpaste.
You said
I'll buy the
Wait.
75 pack of.
You said two Russians?
I need any more.
Two brushes.
Brushes.
Oh.
Two Russians.
Hey,
Two Russians. Oh, man.
hey, I was gonna say I'm gonna go to the closet right now.
Five Russians. What are we talking about?
Alrighty.
Some gymnast girls.
Alright, here's an idea.
Real buff ones or
He says it's going forward and based on a, what does that say right there?
Who knows?
A timer.
You have timers.
Yeah, you,
whatever.
yeah, you have
time
5 seconds.
And this says check
Ultrasound.
ultrasound.
So like make sure it's working.
So you're doing it every so often.
So it'll
Negative.
Okay, so they at least put a timer in there so you're not doing it 100% of the time. That's
That's
an
not
interesting
good.
concept.
What happens if it's out of range and then you go forward and then just.
Well, it's supposed to be going forward and then just checking.
So I guess one of the conditions of this is that the timer is going every millisecond, maybe?
But you have to go all the way through. So it checks it and then you go all the way down.
This is just one possibility.
No, if it checks it and doesn't.
Oh, because it's got a loop up there too. So you're running two different sets at the same time.
Yeah, but you don't need that.
Well, if you think about.
Well, because he's got a loop going this way and this way. So are you checking it or is it going down? Or can you do both at the same time?
No, it's like one's yes and then one's no.
Just one thing.
Now, one thing to point out in the state machine, you can only be in one state at a time. So in that point
That's
there,
what I'm
while
saying.
he's checking the ultrasound, he's totally ignoring the infrared.
And
Right, and then it goes forward a little bit and then it switches to the other one?
What's wrong? Yeah.
During the time that it's doing this processing,
It's not doing
it
that.
will likely still be
And
going
it's not
forward.
going forward. Because he can
It'll-
only be in one state at the same
Well, he can be
at
at
one
one
time.
He can still be going forward, because there's nothing around here that says stop.
It can be coasting, just not accelerating.
he can be going accelerating, doing anything.
I just feel like that was like difficult. I feel like.
But also, you've got timer here. Do you really mean timer, or do you mean something sensed?
Because it checks it and then it sees a clip and then it times 30 seconds to go off the clip.
Yeah.
And then it'll stop.
Yeah, that's right.
So it needs to be cruising into the.
Tell you what, I know you're really proud of your state machine.
But you shouldn't have been to this.
This may be a bit complex.
All right, you.
So let's take a look at what my solution would be.
Okay.
I'm sorry. But you're learning, and that's good to see. So, so what I'm going to do is, I will solve this quickly, and then we will take a break.
Thank you.
Okay.
Or one of these. Wonderful.
We always start with idle, right?
Yep.
Then immediately after a certain amount of time, I said we're going to start, right? We'll go forward. We will use the following. Based on an infrared sensing, we'll use it as a digital pulse. And an ultrasound, a certain value. So we could say any of these, a pulse, a value, whatever, it's going to trigger, we'll have both of these sensing all the time in the forward. Based on the infrared being detected or the ultrasound detecting a certain threshold, you'll do the following. We'll define, let's see, in this case we said centimeters backwards and turn. We'll define, for the infrared we said 30 cm, 90 degrees. In this case of here, we will define,
Wouldn't it stop first?
It could be stopping in there as well.
you can stop in there as well, but I'm going to do it in one state.
Wait, I thought you said you had to break that out.
No. You don't have to because it's software, not hardware.
We are defining, we're not actually doing it.
Oh.
You'll have to do
How do you define?
Yeah, how does one define?
We're setting a variable.
You
It's
like
basically
Setting two variables.
Come on, Ken.
And then you'll execute.
Floating, floating variable?
We're loading a variable. We're stopping.
We can't see where you're going now.
We are turning.
And the
That
rest.
is defined.
Do you want to turn
Hey, don't you
or
want to
reverse?
Basically execute what's defined as.
Oh, I'm sorry. It's reversed.
Yeah, it's reverse center.
Now, at this point, it's still going to be a timer, but the timer is going to be based on this value right here. And that's a nice thing about a state machine. Notice we're doing something identical in both cases with respect to the action, but the stopping condition is going to be preset in a variable. Then the next thing we will do is turn. And based on a timer, and again, that timer is based on that value there.
And you also have to check from that if it sees a cliff.
And if we see a cliff,
You go back
It'll
to
just
the
execute again since of the code.
Wait, but when you're turning,
You go back to your defined state, 30 seconds.
when you're turning, if you're turning in that one spot, you don't really need to, do you?
Back up.
Wait, shouldn't it go back to, yeah.
Yeah.
You got it right.
Because if you think about that, you're turning in one spot. So if you didn't fall off while reversing, you're not going to fall off turning.
that's a good point.
Yeah.
I bet you that would
Unless-
need.
Unless you're like, if you're turning like this, then yeah, but you should just turn like this.
All right, and here's why I want to define this right here. So now we have this set up in a state diagram, and we start asking questions like this. And this is when you start investigating, all right, does this make sense? And it's a lot easier to do it here in your state diagram before you actually start writing the code. So now you start discussing this, and the first thing you would do is you would start conceiving all the conditions where this would fail. For example, would you back up off a cliff? And we had one group that had an idea, oh yeah, you can back up off a cliff in this certain situation. Then what you would do is you would go back and you would change your state diagram to identify, yeah, this would not work, this would work, this would not
But you
work. this
can't,
would
if
work.
you don't have the IR on the back, then if you were going to back off a cliff, you're going to back off a cliff.
It's assumed that it has a
No, the wheels are in the center, so.
But the ultrasound, what did he said there's not an ultrasound or an IR on the
They're both
back.
on the front, so.
They're both on the front.
So
Right.
while you're reversing, you could,
So you could definitely still fall off a cliff and
No.
you could do both.
Well, you could do
wall
just-
or-
you can hit a wall or
You could
fall
just
off a
turn
cliff. Doesn't matter.
360.
You can do whatever you want in
Because
reverse.
by the time the IR sensor senses that it's at a cliff, it's.
You're already off.
All right? So, this is exactly what I want you to do. I want you to look at this and say, all right, now that I've got this state diagram and I'm looking at all the situations that this could happen, and that could happen, and that could happen, I might have this trouble, this trouble, this trouble. That's why you do the design. This is a design up front before you get to the code.
You just take out the reverse and we got it.
So,
I will
this
just put
is...
another sensor on the back.
This would be a great situation or a great condition for you to identify what needs to be done or changed. Could include, for example, saying, I want to add a sensor here or here or here. So, we'll, in a second, we will call it a class, but the quiz will be make a change to this state diagram so that it will not fail.
Are we taking a break and then doing that? Or what?
And so, this is the end of lecture. Thank you.